Observational studies versus design experiments. Lesson objective: distinguish between an observational study and an experiment. Let's start with a medical question. Does the use of handheld cellular telephones cause brain tumors? We'll look at two studies. The first study, the researchers wanted to investigate cancer risk among Danish cell phone users who were followed up for up to 21 years. To do so, they kept track of 420,000 people who first had cell phones during the years 1982 to 1995. In 2002, they recorded the number out of this 420,000 people who had a brain tumor and compared it to the rate of brain tumors in this group to the rate of brain tumors in the general population. They found no significant difference in the rate of brain tumors between the two groups. The researchers concluded, quote, cellular telephone use was not associated with an increased risk of brain tumors. Okay, let's look at study number 2. In this study, researchers examined whether chronic exposure to radio frequency, or RF, radiation caused brain tumors in rats. To do so, they divided 480 rats into 3 groups. Group 1 was exposed to the analog cell phone frequency. Group 2 was exposed to the digital frequency, and Group 3 received no radiation. We call this the control group. The exposure was done for 4 hours a day, 5 days a week for 2 years. The rats in all 3 groups were treated the same except for the RF exposure. After 500 days of exposure, the researchers reported the following after analyzing the data. Quote, we found no statistically significant increases in any tumor type, including brain, liver, lung, or kidneys, compared to the control group. Now, for both studies, the goal of the research was to determine if radio frequencies from cell phones increased brain tumors. Whether or not brain cancer was contracted is the response variable. The level of cell phone usage is the explanatory variable. In research, we wish to determine how varying the amount of the explanatory variable affects the value of the response variable. Now, the way I like to think about it is the explanatory variable is the input variable, is the x variable, and we want to see how does that affect the output, or the y variable. Let's define observational study. An observational study measures the value of the response variable without attempting to influence the value of either the response or the explanatory variables. That is, in an observational study, the researcher observes the behavior of the individuals in the study without trying to influence the outcome of the study. Okay, and there's the key word. Observational study, the researcher is just observing. Just like in study number 1, where they were looking at the 420,000 Danish cell phone users. That was an observational study because they just observed. If the researcher assigns the individual in a study to a certain group, intentionally changes the value of the explanatory, and then records the value of the response variable for each group, the researcher is conducting a design experiment. So in a design experiment, we have a treatment group, the group where the value of the explanatory will be changed, and then we have a control group. Let's look at this example. Does flu shots benefit seniors? Researchers wanted to determine the long-term benefits of the flu vaccine on seniors age 65 or older. They looked at 36,000 seniors for 10 years. They were divided into 2 groups. Group 1 were seniors who got a flu shot. Group 2 were seniors who did not get a flu shot. After observing the seniors for 10 years, it was determined that seniors who got the flu shot were 27% less likely hospitalized for pneumonia or flu and 48% less likely to die. Based on these results of the study, would you recommend that all seniors go out and get the flu shot? The answer is no. The study may have flaws, namely confounding. Confounding in a study occurs when the effect of 2 or more explanatory variables are not separated. Therefore, any relationship that may exist between the explanatory variable and the response variable may be due to some other variable or variables not accounted for in the study. So the flu example is an observational study, and there is confounding going on in the study. A lurking variable is an explanatory variable that's not considered in the study, but it does have an effect on the response variable in the study. In addition, lurking variables are typically related to any explanatory variables considered in the study. What's some lurking variables in the flu study? The age, health status, can the senior get around? The economic status, of the senior, there's plenty of lurking variables in this observational study. Even after accounting for potential lurking variables, the authors of this study concluded that getting a flu shot is associated with a lower risk of being hospitalized or dying from the flu. The key word is associated. Observational studies do not allow the researcher to claim causation, only association. So we can't say that there's a cause and effect. We can only say that there's an association. Thanks for watching.